a multi-stage problem involving trigonometry. So, this question is about two right angle triangles that have been put together to form a compound shape. And we know that it's going to be trigonometry because it involves angles and lengths. Angles and lengths, right angles. So we kind of know that the question is going to be about trigonometry rather than Pythagoras or the sine and cosine rule, which is something that pupils meet later on in year 11. So we know that this must be something to do with trigonometry. So the first thing to do is have a look at what we need. Well, we need this length here. Now it's in a triangle where the only other thing that you've been given is an angle. So we can't straight away find this because to use trigonometry we need at least an angle and a length to find a second length. So we can't straight away find this. So we've got to use this first triangle, which has a shared length here. Okay, so in this triangle we have a length and angle, and if we were to find this length, that's going to then allow us to use trigonometry on this triangle to find this length. Now the most confusing thing about this type of question is not only the fact you're going to have to use trigonometry twice, it's the fact that the triangles are not in the form that you normally like them. So we like normally to see our triangles like this, so why not just change the page around? So if we start by looking at this triangle, then we have a right angle, okay? And the things that we're interested in are this length here, which is next to the angle, so this is A. And the length that we want to find is this length here, which is opposite the angle, which is O. Now, if you were to have started with your triangle like this and tried to reference it up, then you might have got confused about what you've been given and what you need to find. It's always easier if you turn the paper around so that your angle and your right angle are on the are at the base, okay, and then you can reference it more easily. So this first triangle involves an angle which is 50, O, which is what we need to find, which is this length here, and A, which is 5 centimeters. So going back to our previous videos that we did, the trig ratio that involves an angle O and A is TOA, so tan theta equals O over A. Substitute the values in, so tan 50 degrees equals O over 5, and then rearrange this, so move the 5 across the equal sign by multiplication. That gives us a value for O of 5 tan 50 degrees. Now you can work this out now to sense check that it's kind of the value that you want, but I wouldn't recommend then using this in the next part of your question. I'm just going to put some dots there to reference that it continues. Okay, so that is the value for this. Okay, now this next triangle, if we were to turn the paper around so that our angle and our right angle on the bottom, we've just calculated this length, which is this 5.958 and so on. So I'm going to colour code it differently. Next to the angle is A, opposite the angle is O. So again, this is referencing TOA, so tan theta, because it has an angle O and A. So turning it back around. For the second part of the question, we have theta is 38. We have O, which is what we need to find, which is X, and A we've worked out in the previous question, which is 5.958, and so on. Okay, so theta, O, and A is again tan. So tan theta equals X over 5.958. So rearrange, x is 5.958 tan. Oh, I forgot to put in, that's 38. Tan 38. Now, to make sure that you don't lose accuracy marks, you need an exact value for this, okay? So when we try and put this in our calculator, you can either reference it again as this, multiply by tan 38 and put it in your calculator, or you can use your answer key on your calculator, or you can have had it there since you worked it out in the previous question. It doesn't matter which, but you need to use the exact value. So this is 5 tan 50, which I worked out earlier. I'm going to multiply that by tan 38 to give me an exact value of 4.7 for my value of x, because if I don't do that, I'm going to end up with rounding errors, and that's where most people lose marks in a real exam, is through rounding errors. So try not to do that. If you can't help it and you get confused, then maybe it's a mark worth losing, but it's really important that you get used to the fact that if you're in a multi-stage problem, they want you to be putting the exact value in at each point.